This conference will now be recorded.
A very good morning, all. So I hope all of you are doing good. So I have Ashdeep, Divya, Hitali, Jasnoor, Kamal, Kanhaiya, Lakshay, Maninder, Manmeet, Navjot, Neha, Pradeep, Puranjit, Ridham, Roopkaval, Sahib, Sarthak, Shalini, Shalu, Sharan, Shashi, Shifali, Shimpa, Shivani, and Soumya with me as of now. So guys, today we're gonna come up and touch down to the PyTorch. So yesterday I did see some of the messages in the WhatsApp group that you guys have been struggling with your installation with the TensorFlow, right? And good to see that a few of you also resolved the same, right? So today we'll be looking with the PyTorch, right? And we'll see how we can, kind of first of all explore some basic PyTorch examples, and slowly we'll proceed further. So PyTorch is once again a library with the help of which you can work in your artificial neural networks layer, right? So let's begin with an introduction to the PyTorch. So I'm going to write this new Python file, session number 56. All right, so how this PyTorch can work for us, guys, right? For PyTorch to work for us, you need to come up and say import torch. Let us say print the version of the torch. So here we are with the PyTorch version as 1.4.0, right? So your torch is there. So TensorFlow and PyTorch and NumPy, what they have in common, right? They have common as in the arrays or the tensors, right? So I'm just gonna put here. So NumPy, TensorFlow, and PyTorch focuses on tensors, that is n-dimensional arrays. So today we'll explore how we can kind of create these arrays in uh, PyTorch and see some of the examples how we can do various different types of arrays. So I'm gonna come here and say A is your torch dot random 5 cross 3. So you create me an array of some random numbers, right? So this may be a 5 cross 3. So let's print down the A. So quite like NumPy, we are trying to deal with it, right? So when I'm printing this A, so it says it's a tensor, guys, and you see we got this list, right? So five 1D arrays, each array having 3 elements, and they're all random for us, right? So let us also say print me the type of it. So here you can see that the type is torch dot tensor, right? So you always need to understand the data types. They are not automatically going to come up in Python, so you can use this type to understand what is the data type. So the way you created this, so I can say that there is a B which can be a torch dot let's say an empty 53. Let us print this guy called B. Now when I did this empty tensor, so guys, if you see, there is a small difference, right, between the random and the empty part. So in the empty tensor, you do have some of the values coming, not all of them, right? So some zeros and some other values. So either empty or random, it's not gonna be a much difference for us. All right. So it is kind of more importance towards few empty slots, but not all of them. Now I can have the empty is created in a way that I do it with the zeros. So what I'm going to do is I'm going to say C is your torch dot zeros 5 cross 3. So let us print down the C. Now I see an empty kind of a tensor. So when I say empty tensor over here, so it means it's gonna give us some random numbers more or less, right? So if you wanna do it with the pure empty technique, you got the zeros. And yes, these are all floating points for me. So there may be a case that you would like to associate data type. That what is the data type of the tensor which you're going to create. So you can say the data type goes like your torch dot. So you have these data types, for example, integer, right? So now this is your integer 32. So you can even have this with the long. So these are few of the data types which are available. You can explore more of them, right, over the PyTorch. So I'm just gonna share this link of tutorials. So everything with respect to PyTorch, which I'm going to teach, train, or I know is through this documentation only, right? So always explore documentation for your learning part. This is very essential. We try not to follow documentation. We always try to kind of go to blogs here and there, but the documentation is going to be the best source for your learning part. So I just share the link in the file itself, guys. So we can even try to do something different, right? So let's see how. So I'm gonna say that there is this guy D, which is going to be your torch dot tensor. So in the list, I'm going to pass some data here, right? So let's say some number 10, 20, 30, 40, and 50. Then you say print the D. So what happened exactly? You can construct the arrays or the tensor objects yourself. So constructing tensor objects yourself with data. So you pass this list of data here, and it's gonna be done for you. So guys, a smiley waited from all of you. I hope this is clear. Right, guys? Okay, so what is the next thing? So I'll create one of the, let's say we got this guy here. So I'm gonna say D assign. Just give me a moment. D dot new ones. Let's say 5 cross 3 only. So I'm just give me a moment, guys. So what I did, basically, I constructed an array of ones from some existing array by manipulating the data in it, right? So what I did, my D was something else. It was 10, 20, 30, 40, 50. But what I did, I said that, okay, let's create one new array, right? So D dot new ones with the shape of 5, 3. And I have associated this data type. It's up to you, right? So what kind of data type you want to give. So even if you not give it, is going to by default take it as doubles, right? So I'm going to say E is quite like your torch dot random underscore like. Okay, so it's quite like this guy D, where the data type I'm going to change to, let's say, torch dot float. So let's now print E as well. So what we got, so when you said this guy called random like, so you are trying to create some random numbers, but these random numbers, they should be alike your D. So if you'll see and notice, all these random numbers in your new tensor, they are very much close to the values 1. So guys, can I get a smiley from all of you? I think this is clear to everyone. So there may be a case called random and random n, right? So if you are using this random n, so it's gonna include your negatives as well. Okay, so these are all very much close to 1, right? So let us even try to say print me e dot, let us say size, and I will even print coming up here and say e dot shape. So let us see size and shape, right? So when you print the size and the shape, what do you see is either the size or the shape, right? It's the same output for us, 5 cross 3 and 5 cross 3. So NumPy annotation, I mean NumPy terminology, shape can be used in the Pytorch, but Pytorch function is the size, right? So both the operations will work for us. Now we know what is this guy E, right? It's some negative random numbers, 5 cross 3. So I'm going to create this guy F, which is torch dot some random numbers with the same part 5 cross 3. So I will just directly print E plus F. So you can use these operators to do the matrix addition, multiplication, division, everything here and there, right? So we can either use these operators, so use operators to perform matrix operations, or I can even say print me e dot, or let us say this torch dot add, right? So this guy e comma f. So this is up to us, right? Whatever the way you would like, you can proceed accordingly. It can solve the same problem for you. Matrix addition. So there can be one more way. You can say torch dot. You first of all create some result, which is going to be your torch dot empty 5 cross 3, and thereafter I'm gonna say torch dot add e comma f, and you put the output into this result. So I can just say print me the result. So guys, you see the various different ways how PyTorch can be used, right, with respect to these additional operations. We can even come up and say your f dot add, just give me a moment. So I just need to check whether this will go for us or not. Just give me a moment. So what we see is when you say f dot add underscore e, it's gonna add e to f and modify data in f. So guys, just exploring the tensors in the PyTorch, right? So what you are doing as of now is just the exploration of your tensors. Let us see if you would come up and do some indexing on your tensors, right? So I'm going to say print me uh, f, let's say colon comma 1. So I'm just using these empty delimiters. So when I said f colon 1, guys, if you see the indexing technique, right, I'll just put where is my f here. So printing this tensor f and printing out your tensor f. So guys, what I can come up and try to tell you is that during our basic days of programming, we used to call the things as arrays. The n dimensionals were known as arrays. But when you have a lot of dimensions to your arrays, right, we start calling them tensors. Now that's very basic for us to understand. Or a much more, you can say, an advanced way of telling up the arrays is tensors, right? So do not get confused. What are tensors, right? They are nothing but they are the ND arrays. So here is your tensor f, and here is your 1.43980.391462196186. So column 1, right? So what is this? This is your first column in tensor. So I hope this is not that big challenge to anyone, guys. Okay, let me create another Python file. New Python file. This is your session number 56A. So once again, I will import the torch. So X is your torch dot some random numbers with the negatives as well. So let us say this is 5 cross 5. So I'm gonna say Y is your, so before even printing this, let's print X first of all. So these are some random numbers, right? 5 cross 5. So I'm gonna say Y is your X dot view, and I'm going to say 25. print me by. So what did we observe as a difference is that your 2D array was created back to 1D array. If you can notice, guys, right? So this was array of arrays. This is just 1D array. If you try to come up and say this guy over here as, let's say, 10, and now you try to run the program. So what we see is that there is an error. Why? Because you're trying to flatten your array, right? So we are not going to use this view function, right, irrespective of the shape. So view is directly going to construct your array. It's a kind of a resizing for me, where your 2D array gets converted to 1D array majorly. So please see, shape will matter here. Okay. So I'll write one more, guys, z, which is going to be your view of x again, but this time I'm saying -1, 10. Let us see if this thing comes us for us or not. I'm just gonna print down the z as well. So just give me a moment here. So when I said -1, 25, guys, so what you can see is this is your list of list coming out, right? So if you want, you can flatten your 2D array as 1D array, or you can flatten your 2D array as a 1D array in an array. So here, your 2D array converted to 1D array, and here 2D array converted to array of 1D array. So what I will do next is I'll try to print their shapes or the sizes. I can say x dot shape, y dot shape, and the z dot shape. So run the program. So what you get is 5 cross 5, 25, and this is 1 cross 25. So guys, any query to anyone? Would like to get an acknowledgement from all of you. Now there may be a case that we have some tensor which is going to be let's say a random number with only one element. So I'll just print the p. So you have this tensor with only one element. There can be a case, right? So if you want to access the data, you can always use this function item. You can get to extract the item from your tensor. All right. So one very basic thing here, right? Item works where we have only one value in tensor. So this is what we got as in very quick introduction to your PyTorch tensors, right? This was introduction to PyTorch tensors. Let us see how PyTorch and NumPy, they are friends with each other. 56B. So PyTorch and NumPy. So we are trying to come up and see the bridging between the PyTorch and the NumPy. So just give me a moment here. So guys, we'll write few of the snippets. The first one goes like, we created this guy called X, which is your, let me input the torch. So your torch dot ones 5. So let us print down this guy called X. So what we see is that this X is a tensor, right? The type of this X is a tensor. So I'm going to convert it to Y. So in a way that I will say X dot numpy. That's it, right? So let us print this Y. So Y comma, let me print here type of Y as well. So the type of Y is numpy dot array, whereas the type of X is going to be the tensor, right? So if you have the data in your torch, you can convert it to numpy, right? Very easily. And you can even convert your numpy array to the torch tensor. Let us see that as well, right? So I'll just say import numpy as np. Okay, so one more thing which I'm just going to put up here. So this is like once you have done this, so I'll say x assign, or let's say x dot add underscore 1, right? So this is basically what adding 1 to elements of x. So let us print x, and I will also print y. So what I'm trying to put up here is that there is a tensor. You created numpy from the tensor. You are reading numpy from the tensor, right? So when you added 1 to the x, so if you are going to read y, your y will also be impacted, if you can see, because your numpy array is going to be somewhere read from your tensor itself. Please note the difference, guys, here. Can I get a smiley from all of you? All right, guys. So what is the other thing? So this was your PyTorch bridging, and here what we did. So torch to numpy. So guys, this is torch to numpy, and the next which I'm going to do is numpy to torch. Let us see how. So I'm going to say your let's say a is numpy dot ones. So we already studied this part here, right? So I want 5 ones, and your b is going to be torch dot from the numpy called a. So print us a and print us b. So here we are, right? So this is your a and this is your b. I'll just put an extra empty print statement here. So here we are, guys, right? So this is numpy to torch, numpy array, and then the torch. So let us even try to do these operations, right? So this operation goes like numpy dot add a comma 1, right? And the output for us is going to be a. Now let us print a and b. So you did an operation, you did an add operation on numpy, right? And let's see what is the output here. So the moment you change this guy a, b is also updated with the values. So Pytorch and numpy, they form a bridge. So the moment you read a numpy from torch, or you create a torch from the numpy, the tensor torch from the numpy, you modify any one, the other will be modified. So it's a kind of a reference copy which is going to work for us. A smiley waited from all of you guys. I hope this is clear to everyone. All right, guys. So let us see one more thing here. So I'm just gonna write CUDA NVIDIA. So what is this CUDA? So CUDA is a parallel computing platform and application programming interface modeled by NVIDIA. So it allows software developers and software engineers to use CUDA-enabled graphics processing units for general purpose processing. Now, typically, what happens is you will be writing some programs where you'll be doing some graphical processing. I mean to say some image classification, or let us say extracting the details from your various, you can say, data sets, right? There is an image, and I want to extract some details from the image. So you don't want only your CPU should be doing the job. You also would like to take your graphics processing unit or GPU to come into action, right? So Pytorch supports that. So let me come up here and write this new Python file. This goes like session number 56 of C. So the first thing first goes for us is to understand what is CUDA, right? I hope that is clear to everyone. So I'm just gonna give you this link here. Okay, please follow this link. So check if device slash machine supports CUDA operations or not, right? If we can have that or not. So I'm just gonna come here and say import the torch and print torch dot CUDA dot is available. Let's try to run this program here. So guys, if you see, it gives me false here, right? So we don't. There will be few systems which will be having this NVIDIA or GPU support system available, and few they will not have that, right? So this cross check and see if your device supports this operation or not, right? In case if it is going to support these operations, so you can just try to write some other code snippets to fulfill the action. Now for an example, right, in case in case CUDA is available on your machines. In case, right, if it is available on your machines, what we can do is we can say device is torch dot device. So you're gonna say that okay, your system supports the CUDA, and thereafter we can have something like so I'll use this same structure. So your X is some torch dot ones, right? And your Y is going to be a torch dot ones like this guy X, where the device is this device. So typically this is going to be your GPU in action, right? So I'll just put here if GPU support is available, right? Then we are going to use GPU instead of CPU. Can I get a smiley from all of you? But this will not work for us, I think so, right? Because I don't have this CUDA enabled for me. So this is going to be error for me. You can try it on your system. You can just explore it on your systems that how this thing will work. All right, so this was a very quick introduction to the PyTorch, right? What we have in PyTorch. So we'll be exploring more of the PyTorch, where we have these various other tutorials, deep learning, right? Then neural networks with the PyTorch, image, video, etc. and etc. So there is this 60 minutes blitz, right? If you will go to the tutorials here, you'll get the 60 minutes blitz. This is where your tutorials should begin with. You have one small YouTube video to understand what is what here. So here we are with training a classifier. So there are various images here: airplane, automobile, bird, cat, deer, dog, frog, horse, ship, and truck, right? So with the PyTorch, we got this tutorial where we can discriminate what is what. But if you see, this is very much similar to your TensorFlow which we did yesterday, right? So training on the GPU, so there must be the support which should be available, only you can do it with the GPU. So other way around, you can work on the CPU part only. So this is done with the help of something known as CNN. If you see, convolutional neural network, so which is way beyond your basic artificial neural network model, right? But this will see tomorrow. This example we're gonna see tomorrow. We're gonna understand what is CNN, how it's gonna work, and thereafter we'll be able to proceed with this example. So a very quick introduction to PyTorch. I hope this is clear to everyone. And now the next introduction for us is going to be this scikit image as library. So guys, what is this scikit image or SK image, right? This is something which I'm going to take down to your next tutorial part. But before that, anyone having any query, you can please raise the same. So guys, I hope we are good to go till here. So for SK image, you need to say pip install SK image. Pip install SK image, right? This you have to write. So I have already installed this SK image on my system. So this is scikit image. Once again, image processing by the Google, right? So they have open sourced this part. So I'm just gonna give you a small demonstration on how we can use this image processing library in Python. Okay. So we got this data set. So this data set over here is known as faces. So I'm just gonna add it to the Git as well, or I'll share this data set over the WhatsApp, guys. Right? It's a zip file I should be sharing with you guys. So there are few faces available here and there. So if you see, this is a good resolution image, right? 375 by 500. It's a face. So on the face, we would like to detect the eyes, the nose, and the lips. Quite very much similar to what we did in our OpenCV. Okay. So there is something known as landmarks. So when I say landmarks, so they mean your various features over the face. So there is an image name, right? So there is this image name. So there is part 0x, part 0y, part 1x, part 1y. So this is a data set which has been created, right? So every part describes a certain feature on your face. All right, and these are the coordinates, your x coordinate, y coordinate, x coordinate, y coordinate, right? So how is this CSV file created? So you got these images. So we have these images here, and there is something known as create landmark dataset.py. There is a Python file which is kind of creating this data set for us. All right, so we don't have to deep dive much here. So coming now to your another program, I'll write this 56D. So we got, let us import pandas, importing pandas as PD. So I'm gonna say landmarks is your pandas dot read a CSV file. Now this CSV file is available under a folder faces, and the name of this CSV file is your, let me check that. Face underscore landmarks dot CSV. Face underscore landmarks dot CSV. Right? So I'll just say print me the landmarks. Let us see if the data set is read for us or not. So here we are with the data set. So there are these 69 images, right? So each image has 137, I mean to say there are 137 columns, 136 we have these x coordinate and y, right, which is going to describe a certain point on an image. So coming here, I'll just say, let us take some number here. So this number is going to be 60. I'm just using this 60th image in my data set, right? So I'll say image name is your landmarks dot iloc num comma 0. So let us say print the image name is comma image name. Just give me a moment here. So the image name is this image name, right? So I can see this last 68, right? Or 67. So I'll just put this number as 67. Run this program. So I see this 67th image name coming up. Guys, can I get a smile? The basic your pandas and the data set exploration, right? I think nothing much difficult for us over here to understand. All right, guys. Now, next is I'm going to say something known as landmarks. So I'll use this guy as a data set, right? So landmarks data set is a much more better name. So I'll say landmarks is what? It is your landmarks data set dot this I number. So then after the one, right? So zeroth was the image name. So this zero was the image name. So from one till end. So in the data set from first column till the last. So if you observe here in the data set, which is the CSV file, so the zeroth was the image name from 1 till the end, right? So these are a total of 67, but if you multiply it with 2, right? So because one is X, one is Y. So I'm considering all these columns. So I got these landmarks and I'm going to say dot 2 underscore numpy. So I got this landmarks right as in your numpy. So let me just come here and see printing landmarks. So I got the data coming as numpy for the number, right? For this number nth image, right? So let's say this is image, right? Image number 67. So I got the name of the image number 67 and the landmarks. Guys, what are landmarks? Landmarks, they are the points on the image where we are going to kind of denote certain features. They are the X and Y coordinates, right? So if you will see here, so these are the X and the Y coordinates, right? So I got it for this 67th image, which is this guy, person underscore this, or let it be for 60th image because I am quite familiar with the 60th image. It's a good image when I will display the content. So this is the 60th image, right? And the 60th image here is this 96063. This is the image, right? And this is the landmark 162, 177, 165, 198. Guys, are we good to go? The highlighted line, the highlighted row here, and the extracted data below. Acknowledgement awaited from all of you guys. All right, guys. So coming next is I want to show this landmarks on the image with some points. So I'm just going to write few more code snippets to do that. So I'm going to now convert the landmarks, right? I'm going to reshape the landmarks and I want to convert them as floating points. So I'll say landmarks is landmarks dot as the type, and the type over here is going to be float. You say a dot of reshape -1 comma 2. Let us print the landmarks now. So what I did is reshaped landmarks array. So print the landmarks now, right? So this was the previous landmarks. You can even say landmarks dot shape, and here also I'm gonna say landmarks dot shape. So previously this landmarks was just one list, right? Now what I did, actually I got a list of lists. So 162, 177 is 1 point. 165, 198 is the another point. 170, 219 is the other point, right? And the last point for me is this guy called 245 and 256. So reshaping, because here part 0x, part 0y, part 1x, part 1y, right? So on the face we have various parts, and for that parts you got this x and y coordinate. So we sort of reshape the data set so that we can have these x and y coordinates coming out for us. Now once I have reshaped this entire part, right? So what I'll do is I'll say from the SK image, import IO. So IO is a very basic module in the SK image. This is majorly to read the image. Okay, so you can read the image and you can use it. So what I can do is I can define all this thing in my main function. So I think this is like good to go for everyone. So I'm going to define show landmarks as one function, right? Which will take image as input and landmarks as input, right? So once you have reshaped your landmarks array, so what I want to do is I want to execute this function called show landmarks, right? So guys, now I will say io dot image read. So you are basically going to read an image with the sklearn. I mean, sorry, sk image, right? So here I'm going to say os.path. So I'll even import another module called import os. So os.path dot join. So I have these faces and a slash with this guy called image name. And the second input is going to be landmarks. Guys, is this line number 29 clear to everyone? So with the SK image, I'm going to read the image from this path, faces slash image name. So I've just introduced this OS module once again, right? So here you get to have the path of the image, and here you have the landmarks. Now what I will do here, I'll use my matplotlib to come up and show the data. So I'm just going to say plot dot image show us this image. So when I say io dot image read, it has basically converted your image into your numpy array basically, right? So that's how we deal with it. And after showing the image on the plot, I'm going to create a scatter plot. So this scatter plot is going to be landmarks of column 0, and I will even put the landmarks of column 1. So what I'm doing here, so guys, if you can recall this 0th index and the 1 index, right? So this entire 0th column and the entire 1 column, so x coordinates and the y coordinates, I am printing it as a scatter plot, right? So let us take some size as 100, and there may be a marker which can act as a dot. So I just want to put up a dot, and if you want to have a color, let's use basic C over here itself is R. The color is red, right? And lastly, I'm gonna say plot dot show. So now let us run this program. Okay, it says X and Y should be of the same size. So just give me a moment. Oh, my bad. Colon, comma 0 and colon, comma 1. So here you are, guys. If you see the landmarks, what exactly landmarks means, the features on your face, right? So we see these dots coming up, highlighting where exactly is your face, what is the face cut, where are the lips, where is the nose, where are the eyes, right? This is the image number 60. Let me change the image number to 50. Let's see the image number 50. So this is the image number 50, right? The face cut, the eyes, the nose, and the lips, right? So there may be some another image. Let's say, let's try with image number 40. So here we are, right? So if you have the images with you, in case you have images and you wanna draw landmarks on the images on the face, typically face, we got this Python file, create landmark dataset.py. The main role of this Python file is to come up and detect the faces and draw the landmarks, right? So this is the file which is going to create the data set for us, okay? And at the same time, for every person, right, there will be x coordinate, y coordinate, various features which are denoted by these points, and we got a program where we can highlight the landmarks on someone's face. Let's go with some image number 30. So if you see, right, very precisely it is detecting so let's say some image number 20. So I'm just taking some random images from the data set, right? So here we are. Let's say the image number 10. So I hope we are good to go with the program here. So just a very quick introduction to PyTorch and the SK image with the landmarks data set, guys. So you can explore SK image. SK image is something which I'm not going to put an exploration on. So this is something which I wanted to introduce to you people. You can go to this gallery here. So you can see some set of examples here. All right. So this I will put across in session 56D. So this is what we got for the day, and I hope you have enjoyed the session. So anyone with any query can please raise the same. So tomorrow, guys, you're gonna have a session on how we can create the artificial neural network, right? ANN. So we'll be thereafter looking forward for CNN, RNN, then mask R, CNN. So you have different ANN models which we are going to study, right? And they will be really impactful for you guys to learn and to implement in your projects. At the same time, I haven't received any project sheets. So you can please send me your project data or the TXT file which I requested in the same WhatsApp group. Don't send me individually, right? Just send me in the same WhatsApp group, guys. So regarding the installation problems, so we need to tackle them, right? You have to see the 32-bit, 64-bit part. You have to see your updated Visual Studios and the other stuff, guys, right? So I may not be of much help because R&D and exploration has to be done on the installation part. So whosoever is still struggling, so please post the issues in the WhatsApp group once again, right? Because yesterday few of you have already solved the installation related concerns. So other than this, guys, anyone with any query, a smiley waited from all of you so that we can proceed towards closing the session.